astronomers have found a new planet, Proxima B, not too far from Earth. They recently used the James Webb Space Telescope to get the clearest picture. This planet goes around the nearest star to our Sun, giving us a good look at another world. This find has made scientists excited. How did the telescope get such a great picture? Could this planet have what it needs for life? What does this mean for what we know about planets outside our solar system in the universe? The James Webb Space Telescope's image shows Proxima B, a planet orbiting Proxima Centauri, the closest star at just 4.2 light-years away. This first clear look has made us wonder if it's like Earth, maybe with oceans with life. Proxima Centauri also has another big planet, Proxima Centauri. See, Proxima B gets about the same energy from its star as Earth does from the Sun. This makes researchers think it might have water or life. There are lots of exoplanets, planets around other stars, and the universe is 206 trillion stars. Some of these planets wander around in space. Proxima Centauri B is special. Year is only 11.7 Earth days. It orbits its star much closer than Earth orbits the Sun. So, one side is always in sunlight and the other is always dark. Proxima B was first found using the radial velocity method, which spots planets by seeing how they make their stars wobble. The changes in the star's light showed that Proxima B was there, proving this method works for finding planets. Finding Proxima B was a big deal because it's in the habitable zone of the closest star to our Sun. This discovery has made scientists and space fans eager to learn more about Proxima B and what it means for our understanding of the universe and the chance of life out there. Imagine 3 stars, Regulus, Canopus, and Proxima Centauri moving together in space. They're the closest star system to us. Regulus and Canopus are bright in the Leo constellation, ranking as the 3rd most brilliant. But Proxima Centauri, also known as Alpha Centauri, is more interesting. This red dwarf star is not far from its brighter companions. It's named Proxima Centauri because it's the closest star to us. You can't see it without a telescope because it's not very bright. Red dwarf stars make energy through strong activity inside. This star will stay as the main star for a long time, but life around Proxima Centauri might not be easy. Proxima Centauri is a flare star with sudden bursts of energy. Its lower mass means the area where life could exist is closer than our Sun's. Proxima B is in this zone about the same distance as Earth is from the Sun. But things aren't what they seem. Proxima B gets intense ultraviolet radiation much stronger than what reaches Earth. This radiation is dangerous and can affect important elements like nitrogen and oxygen. Just because Proxima B is in the habitable zone doesn't mean life can be there. It might not have the right conditions to support life, control the climate, or have a surface with water. Without a strong atmosphere, any life would be exposed to harsh conditions, making it less likely. Scientists are still trying to learn about Proxima B with the help of tools like the James Webb Space Telescope. This telescope could answer a big question. Is there life on Proxima B? Finding out the truth about Proxima B isn't easy. The James Webb Space Telescope was improved to take clear pictures. A physicist says Proxima B needs a careful study. It's in the habitable zone and can absorb and send out infrared light which the telescope can see. The telescope can capture faint light from the planet to find water or an atmosphere. Whether Proxima B has water is important. If it does, it would increase the chance of life. It gets about the same solar energy as Earth, but because it's close to its red dwarf star, it gets strong radiation and magnetic activity. This could affect any atmosphere. Scientists are using models and simulations to study Proxima B's environment and water sources. Some think there are big oceans, while others believe the water is ice or hidden underground. Finding water on Proxima B is hard and needs advanced telescopes and specific conditions. As technology gets better, we should unravel the mysteries of Proxima B. But having an atmosphere doesn't mean Proxima B is right for life. Astrophysicist warns that Proxima B might be like Venus with a thick atmosphere and extreme temperatures that make it hard for life to exist. Proxima B is an interesting neighbor in space. It gives us hope for life-friendly conditions. It's close enough for future missions, capturing the attention of scientists and space fans. Traveling to Proxima B is hard now, but it's a long-term goal for interstellar travel. Getting to Proxima B would take a long time with current technology, but people are coming up with ideas like solar sails, which could get a spacecraft to Proxima Centauri in just 20 years. This could make exploring an Earth-like planet possible in our lifetime. The discovery of Proxima B has sparked our interest in space again. It shows our desire to explore and think about life beyond Earth. The James Webb Space Telescope is great, but has limits. It can see planets and look for signs of life, but it's hard to know for sure if the conditions are suitable for life. Proxima B, possibly like Venus, tells us that just having an atmosphere doesn't mean life is possible. So, the telescope is so good at seeing faint signs of life. It has great potential. The universe has many planets waiting to be explored. These exoplanets come in different sizes and types. Some are big gas giants, while others are more like Earth. Gas giants are interesting to astronomers. They're like bigger versions of Jupiter and Saturn. There are hot Jupiters, gas giants that orbit very close to their stars and get extremely hot. Studying these planets shows us violent storms and extreme heat. There are also Neptune-like exoplanets smaller than gas giants. These include hot Neptunes and many Neptunes which have puzzling atmospheres. Learning about exoplanets like Proxima B has pushed us to create new technology and understand more about the universe. As we find more exoplanets, methods like the transit method, where we see a star dim as a planet passes in front, have helped us find and study planets. We're also looking for biosignatures, chemical signs that could mean life. The James Webb Space Telescope can look for gases like oxygen, methane, and carbon dioxide, which are linked to living things. If scientists find biosignatures on an exoplanet, it would strongly suggest life exists elsewhere. As we look at the stars, the search for life continues. The JWST's first mission will focus on the TRAPPIST-1 planetary system, located about 40 light-years from Earth. This system has 7 rocky Earth-sized planets orbiting a quiet red dwarf star. 3 of these planets, located in the habitable zone, could have liquid water on their surfaces. Although the TRAPPIST-1 star is smaller and cooler than our Sun, it emits a similar type of light due to the planet's close orbits. Proxima Centauri, a red dwarf star 4.25 light-years away, might be the best bet for finding city lights outside our solar system. Proxima is much fainter than the Sun, so a planet would need to be much closer to it than Earth is to the Sun to support life. In August 2016, astronomers discovered a planet with 1.3 times the mass of Earth in the habitable zone, where the light intensity is just right for liquid water. This planet, Proxima B, orbits Proxima Centauri. However, Proxima B might be an airless, lifeless planet, because it orbits its red dwarf star at a distance of only 4.6 million miles. It's exposed to strong solar winds that could strip away its atmosphere. Still, Proxima B gets enough sunlight for temperatures and liquid water to exist, similar to Earth. Since it's so close to its star, Proxima B is thought to be tightly locked, meaning it always shows the same side to the star like the Moon does with Earth. Proxima Centauri has about 18% of the Sun's mass and emits much less light, only 5% of the Sun's brightness. Even though it might seem like a barren, scorched planet, liquid water could exist on Proxima B if it has an atmosphere to trap heat. Since it receives only 65% of the energy that Earth gets from the Sun, the planet might not be very friendly to life. Still, it's the best candidate because it's tightly locked. Proxima B has permanent daylight and night, leading to extreme temperature differences. Proxima also receives almost 3 times the high-energy radiation that Earth does, including X-rays and ultraviolet light. Unless it has a protective magnetic field like Earth's, the conditions for life might not be ideal. Despite this, favorable conditions could make Proxima B a more welcoming place. Unfortunately, models suggest that tightly locked planets might lose their atmospheres quickly because gases freeze. On the night side, on Earth, volcanic activity replenishes our atmosphere, and a strong magnetic field helps prevent it from escaping. Since we don't have much info about Proxima B's volcanic activity or magnetic field strength, we can't say for sure if it has an atmosphere. Still, an atmosphere suggests the presence of oceans, and together they suggest the potential for life. There's still hope that Proxima B has a complex biosphere. It might have solar-powered charging stations on the day side to generate energy for lighting and heating the night side, which would otherwise be too cold and dark to live comfortably. The discovery of Proxima B has led to a rush to find out if it passes in front of its stars seen from Earth. These transits would allow scientists to determine the planet's size and mass, assess its density, and confirm that it's made of rock. During a transit, starlight could pass through the planet's atmosphere, but the chance of the orbit being aligned just right for scientists to see a transit is only 1.5%. The star's tendency to erupt also makes things difficult. According to astronomer David Kipping of Columbia University, the star is unstable and solar flares cause a rocky planet to absorb sunlight and emit it as infrared light. Luckily, rocky planets produce a certain type of infrared radiation from stars like Proxima Centauri, and the James Webb Space Telescope was designed to detect infrared light. Proxima B's infrared signature is important for identifying its atmosphere. The JWST's infrared capabilities are much better than Hubble's, which could allow it to detect city lights on Proxima B's night side, even if they are as faint as those on Earth. The JWST could spot artificial lighting if it's limited to a frequency band much smaller than the star's light. Proxima B's dayside might be covered in solar panels that reflect starlight. As Proxima B orbits its star, it experiences constant day and night with extreme temperature changes. The temperature difference between day and night will depend on whether the planet is made entirely of exposed rock. If it lacks an atmosphere, Proxima B's temperatures will change dramatically. The day side will radiate all the energy it receives from Proxima Centauri as black body radiation, while the night side would be a frozen wasteland. If the temperature difference is less extreme, it could mean that the planet has an atmosphere. It will take the JWST just